Morning, folks. So after that kerfuffle with the AdCom, I'm going to go back to just doing repairs for a while. It scarred me for life. I hate making errors like that, and especially hate making errors that I don't catch when I'm showing the video. So please, if you watch the AdCom video about the protection circuit installation, please watch the following one where I correct my screw-ups. In any event, going back to Sansui, going back to a straight repair. This is a Sansui AU719 integrated amp. I bought it from eBay. Seller disclosed it had a bad power transformer, but he was including two transformers, which weren't photographed with the part numbers exposed, or I would have realized they weren't the correct transformers. They were for an AU717. Very similar amplifier, but they are not the same part number, and I was not going to install them. I have had this for a while. Well, it so happens that the gentleman I fixed the Mitsubishi power amp for was grateful, and he sent me the correct transformer for this guy. So thank you, Jason. That was very much appreciated. So we're going to take a look at this. Now, we're also going to have to talk about black flag capacitors. If you've been doing any reading on these amplifiers, you may have come across these. And we're going to start with a discussion of those before we even get into anything else here. Okay, so in order to understand why it's so important we need to remove and replace the black flag capacitors on here, we need to understand why they're here in the first place. Now, they're a type of polystyrene film capacitor, and they have been proven to be failure prone over the years. I'm not sure what the failure mode is. There's a gentleman who has a website that is conradhoffman.com, and he has a really good write-up about this. There was a gentleman named Glenn with two N's on a popular audio forum I'm a member of. He was the one that understood and figured out the root cause of why amplifiers were self-destructing. And why would a failed capacitor of a very small value cause that? Well, let's take a look at the specs for the AU719. We're going to talk briefly about the AU919. And I want to point out the frequency response. From DC to 400 kilohertz, that's 400,000 hertz. The AU919 is DC to 500 kilohertz, getting dangerously close to the AM radio band, which begins at 540 kilohertz. Now, you may ask yourself, why do you need the amplifier that goes up that high in frequency response when the range of human hearing tops out at 20 kilohertz? And as we get older, it drops precipitously from there. Trust me, I could probably sell everything but my subwoofer these days. But the reason they did that is they wanted what they called fast amplifiers. Now, a fast amplifier will be very high in frequency response, will have very low rise time and slew rates. Rise time is the time it takes for a square wave to rise from 10% to 90% of its value, and slew rate is measured in volts per microsecond. How many volts you'll get per microsecond. Now, these don't see 170 volts, of course, but it's just a spec. Faster the amplifier, the lower that'll be, the higher that'll be. So the reason they did this is they had discovered, or it was becoming an issue, whether real or perceived is another story for another day, of a phenomenon known as transient idromodulation distortion, or TIM. And the solution was to speed up the feedback network in your negative feedback. Now, if you recall, negative feedback comes from your output stage and goes to the differential pair in your input. This is a dual FET that they use in the input for the differential pair. Your signal goes in here, negative feedback goes in here. The problem that they discovered is by the time a signal propagated through the circuit, through the outputs, and went back to the feedback side of the dual FET here, there would be a lag introducing a type of distortion. They called it TIM. So the solution was to make the amplifiers faster. Now, there's a trade-off in pretty much everything in electronics and life, and the trade-off here is fast amplifiers, when used like this, can easily oscillate. And if an amplifier like this self-oscillates, where you'll see a sine wave on the output for no input, it can rapidly destroy the output transistors because the oscillation is usually very high in frequency. Solution was to use what they refer to as feedback capacitors, very low values of capacitance between, let's see, the source and the gate. I've always been bad about FETs because they don't look like transistors where it's easy to see an emitter from a collector. A FET has a gate, a source, and a drain. This is one of the black flags, so I'm assuming it's going from the source back to the gate. And a capacitor like this, and I'll show you one further along in the circuit, this is easier to understand. Here's our collector, here's the base. It's going to feed your signal back 180 degrees out of phase. And since it's a very low value capacitance, nothing is going to pass through it until the frequency gets high enough. So if the frequency rises to a certain point that's dangerous, the capacitive reactance will drop, and this will have a path back here to the base, and thereby it'll attenuate or dampen out any oscillation. Problem is, these black flags can go south. You have nothing to dampen your oscillation. Your transistors can oscillate, go into thermal runaway, and bang, there goes your amplifier. So, what do these things look like? I'm going to pause here and I'm going to show you the output module from this. I believe there's only 2, possibly 4 black flags in an AU719, but there's a good 26 of them in the flagship AU919, and they need to be addressed. I had one come across my bench. Guy told me, yeah, when I put it in phono, the amp goes into protection. And it did because the phono stage was oscillating. Okay, I pulled one of the output modules out of this amplifier, and the black flag capacitor is this guy here. Now, it looks a little like a rectangular black flag, and the gentleman, Glenn, who determined that this was failing and causing amplifiers to oscillate to destruction, kind of paraphrased the old black flag insecticide ad they used to have, which was kills bugs dead. He said black flag kills amps dead. I thought that was kind of cute. But these guys have to be removed, and I'll show you what we replace them with. These are what they call multi-layer ceramics. And so this is a 22 picofarad. At least they're large enough to just put the number 22 right here. So what we want to use is wow, where did they all go? This is 100 picofarad C0G. These are what they call multi-layer ceramic capacitor, or MLCC. These are axial. The ones I get are radial, with leads coming both out of one end. And let me pause here. I'll see if I can find them. I don't know how I misplaced them. Okay, they got misfiled. Sorry about that. But anyway, the 22 picofarad. Look like this. They're tiny little guys, and they replace these huge black flags. So as I rebuild this module, replace electrolytics, replace trimmers, re-grease transistors, replace small signal transistors, those black flags are going to be replaced with this. Okay, so I've got the bad transformer pulled. Now I'm going to show you the good one first. If you take a look, these windings look nice. They're brown. But if we look at the bad one, you can see how charred it is, especially down here, the windings that are closer to the body of the transformer. And you can see how discolored this is compared to the good one. So something caused this to burn up, and the first thing I'm going to want to check are the fuses. For whatever reason, I have read that more transformer failures in the AU719 than the 919. I'm not sure why that would be, because they both appear to be adequately fused. But in any event, this transformer was clearly bad. So we're going to install the new one, and then we're going to have to put the output module back in, and we're going to see what kind of shape this thing is in. Okay, I have the new transformer just physically mounted. It's basically just a matter of putting it in and tightening these 4 nuts. So it's physically in there, and now we're going to have to splice all the wiring back in that was cut. Fortunately, everything is color-coded back here, so it should be a pretty simple job to just solder all these wires on. And then the secondary side is going to go to this board right here. This gray wire goes to the ground bar. These 2 purple wires go here. It's AC voltage, so there's no polarity. One's just as good as the other. Okay, so I have all the wires from the primary side of the transformer soldered onto the multi-voltage terminal strip back here. I have the secondary plugged in, and I have the center tap going to ground. Now here's a lesson I had to learn the hard way, like the way I learned most of them, is that if you want solder to adhere to a piece of metal, you need to sand it, use some steel wool, something to make the metal bright and shiny. It's just like the fact you can't weld rust, you can't solder to tarnish. It won't work. So I buffed this with a piece of sandpaper until I saw clean, bright metal, added just a drop of flux to it, wrapped it around, and we have a good solid solder joint. So I'm going to crank this thing up through the dim bulb tester, and we're going to see what we get and see if this thing comes out of protection. Spoiler alert, after that last video, I tested it. It does. So here we go. Bright bulb dims down as the filter caps charge up. We look over here. Our protection light is flashing. And it just came out of protection. So we're going to try feeding some signal into this and see what we get. Takes a while to come out of protection. That could be either from the dim bulb, or it could be that the filter capacitor, I'm sorry, not the filter capacitor, but the timing capacitor for the protect circuit is getting old, maybe high ESR, low capacitance. In any event, this thing is going to get a complete rebuild, and I'll document that process. Okay, so I have this connected now without the dim bulb tester, and we're going to watch the power LED over here and see if it comes out of protection quicker, and then we're going to put some signal in, see what we get. Okay, so it does come out of protection. I have a small amount of signal going in, so let me show you the scope. Okay, the volume control doesn't seem to have a lot of effect on this. Yeah, we still got some problems here. And I'm going to check. This doesn't have a pre-main switch on the back like the 717, but yeah, we got some problems here. Okay, I'm going to try the tuner input and see if that looks any better. Okay. We may have a problem with our volume control. Let's see here. We may have some dirty switches. Okay, so yeah, we're gonna have to clean the volume control, which is gonna require disassembly. And I'm gonna put in a little more signal. Oh, brother. Yeah, we got problems here. Well, that's good. That'll give us something to make another video out of. Anyhow, we have a new transformer in here. And we're getting more than enough out of one channel and nothing out of the other. So the right channel is giving us our rated wattage of 90 watts per channel. We have 42 here. It's probably a dirty switch or the volume control. Okay, if you look at the distortion analyzer, we got 97 and 42. Balance control does not look bad. Okay, so we're going to have to find out what the problem is. That's another story for another day. I got to clean all these switches, and that may take care of the worst of this. Oh, look at that. Clean the switches. So we now have 98 and 99 watts. So I'm going to drop the signal into it. Okay, so it's looking pretty good. So we got 89, 91 watts. Our distortion is 0.03 and 0.06, which is a little high. It's supposed to be according to our specs. Our distortion is supposed to be 0.015%. So we got some work to do, but mainly we're gonna have to clean this. I'm gonna rebuild it, and then we'll take it from there. Okay, so the front panel is going to have to come off so we can access the volume control on this guy. Volume control appears to have a problem. Unlike the AU717, seems like most of these knobs pull off with the exception of the volume control. So we can just pop these off. And then all we're going to have to do is use an Allen wrench on the volume control. Believe it's a 1.5. I don't know if it's different than the 717. I do know it's about as hard to get in as the one on the 717. Okay. All right, so now we just take a few screws off around the perimeter and the front panel come off. From there we can access the volume control. Okay, so the front cover is exposed, been taken off to expose the under part. There's a screw here, screw here, screw here, screw here, front panel pulls off. Like the AU717, there are connectors that look like this that plug onto LEDs that are glued on the inside of the panel like this. And you can see the pins are exposed here. And also like the AU717, I tried to pull them off because I forgot about those. So now we're going to take the shield off here, and then we can unscrew the retaining nut that's holding the volume control on. Well, take a look at that. Probably going to have to be disassembled. Okay, so on the back of this volume control was a cover, and from the front there were two long screws like this that went in. When I removed that, I was able to remove the back cover and spray the surface of the potentiometer here. Then I spread some of the other ones so I could get contact cleaner into those and spray them. I didn't want to completely disassemble this. This has the kind of compression ring that you have to almost destroy to get off. Hopefully you can bend it back into shape and reuse it. Otherwise, I would have to find a source for them. But as it turned out, this was good enough, because once I did that, now when I turn it on and we take a look at the distortion analyzer, and I'm going to move it so you get a good view. We have good output both channels. There is 1.5, 1.6 watts. There you go, 6 and 7, both channels. Everything's looking good. So we have around 11, 12, 8, 17, 18 watts. So I'm just going to go up until we start to see a clip. Right there, turn it back down a little. And there we go, 90 and 93 watts, 0.04, 0.05% distortion. So the volume control was causing all our problems. So I am going to turn this off, and we're going to put the volume control back together, and I'm going to have to start the rebuild process. It's fairly laborious, and I will try and keep the videos as brief as possible while also telling you all the steps I took. Anyhow, I'm going to stop this video right here. I thank everyone for watching, and as always, I like giving back to the community that's given me so much. Thanks a lot, folks.